have a shared view of risk to our farms from these compounds. And third, give you a little snapshot of what's happening at EPA on the regulatory front with PFAS. And it is a very dynamic landscape right now there. Okay, so let's start with that first one. Okay, we've got a little glitch here. So I'm going to talk about the class of compounds, per and polyfluoroalkyl substances, PFAS, and we refer to this class of compounds as an impressive class of pollutants. We like to use those kinds of words in science, and I'm going to show you eventually a list here of why it is such an incredibly complex. Oh, we're almost there. Okay, here we go. All right, so this is a quick chemistry 101 for us here. I won't go too far into this, but we have this class of compounds that we're still trying to define. We know that there are thousands of precursors, so those are chemicals that can turn into PFAS, parent compounds of PFAS, and then they're degradates. As they're metabolized in the environment, they turn into other things. And all of those three, precursor, parent, and degradates, are potentially risky, and we're trying to understand the science. We see estimates of over 10,000 different PFAS compounds. In fact, our USGS colleagues use the estimate of 12,000, but I've seen higher numbers. So we're still trying to define this class of compounds and how many versions of it are out there. They are extremely persistent, bioaccumulative, and toxic, PBT. PBT is a way that we have characterized the risk of pollutants for a very long time, and this class scores incredibly high on these three factors. They are very persistent due to the strength of the carbon to fluorine bond. They do bioaccumulate in both fish and humans, and unfortunately that would all be bad enough, but they're very toxic. And what we're seeing with the development of things like drinking water standards and how low those values are in our proposed maximum contaminant levels in drinking water, they're extremely low because unfortunately these things are very toxic to living systems. So we have the perfect storm here in terms of very high persistence, tendency to bioaccumulate, and toxicity. Now, adding to that, there are many, many sources. So as we approach trying to do a better job of managing risk from these pollutants, we have to realize that they're coming from many, many sources, and that's going to make it more challenging. And they're used so widely. If you've been following this topic, you've probably seen some indications of how widely these things are used in commerce, from fabrics, it's Teflon, it's anything that purports to be non-stick and stain resistant and water repellent. Any of those products are likely to have PFAS related to them. So that's what makes this such a challenging and, as we say, impressive set of pollutants that we are really just learning about. We categorize these as emerging pollutants of concern because our science knowledge is really just developing now. So real quickly, it's not what I wanted. Here we go. Okay, yeah, so I just want to take 1 minute and familiarize you with the structure of these compounds, because maybe when we know them, we're a little less fearful of them. But what we've got here are the two that are being worked on most most readily in our regulatory scheme, and that's PFOS, perfluorooctane sulfonic acid, and PFOA, perfluorooctanoic acid. And what we have in these compounds is a carbon chain. So what you see here are points along this compound that are carbon molecules, and attached to them are fluorine molecules. These carbon molecules are saturated with fluorine. Fluorine to carbon bond is one of the strongest bonds that we know of in chemistry. Fluorine is extremely electronegative, which means it wants to bond with things. It's always looking for something to bond with, and when it does, it's a very strong bond. So this carbon to fluorine bond is part of the issue here. Very hard to break. So our treatment technologies are looking at how do we break this bond, because it's very hard to do. So we have a carbon chain that's saturated with fluorine, and then at the end we have what we refer to as a functional head, the functional head. And you can see that that functional head is different across different compounds. This sulfonic acid has at its functional head an atom of sulfur that has 2 oxygen molecules attached and then a hydroxyl group. And it's the functional head that really gives it a lot of its performance that is so desirable in commerce. Things like water resistance and oil resistance, and this carbon to fluorine bond is what gives us such a challenge in developing technologies to break it. So in terms of remediating these things, there are 2 ways we can do it. We can filter them out. So drinking water, for example, can be filtered, but then we still have a media that's got PFAS on it. We've got to do something with that. So there's filtration, there's also destruction. We would rather destroy this compound. There's a lot of work going on in universities in particular right now to develop technologies to break that carbon-fluorine bond. But so far, most of what we see requires a lot of energy, and they would be hard to scale up. So in terms of dealing with this stuff, we can filter. The destructive processes that we would prefer are still being developed. Okay, so that's a little intro to the chemistry here. Let's spend a couple minutes making sure that we understand what this means to our farms. So this is a conceptual model that's showing some of the sources to the farm. And here's the first one, which is water, groundwater. If the farm's groundwater is contaminated and it's being used for irrigation or to water livestock, there's the potential for it to be entering the farm through groundwater. Also, we know that biosolids that come from municipal wastewater plants are often used as soil amendments on farms. And if those biosolids are contaminated, then we are adding those to the soils on our farms. So biosolids is definitely another source to the farm. And finally, pesticides. Pesticides and the presence of PFAS in pesticides is something that we're trying to understand better. In fact, we've got next month our 17th annual Pesticides in Chesapeake Watershed Conference, and we're going to get an update on what the science is telling us about the presence in pesticides with PFAS. We know there are 3 possibilities. First of all, that the containers that are used for pesticide formulations are fluorinated to improve their performance, and that can contaminate the pesticide mixture. We also know that there's adjuvants, things that are added to pesticide formulations to make them work better, that could fit into this class. And then finally, active ingredients themselves that fit this definition of a fluorinated compound. So those are 3 different ways that pesticides may be PFAS may be part of our pesticide formulations and just could be adding another source to the farm. So from all of that, we get PFAS in soil, and we're showing here that there are a few risks then. PFAS really is potentially with us in all manner of exposure. Orally, we can consume it through contaminated water and fish and food. We can inhale it, and we can pick it up dermally when we're wearing fabrics that are high in PFAS content. So all vectors of toxicological risk are in play here. And this is showing that farm workers with contaminated soils can inhale or otherwise be exposed to PFAS. Another thing about this class of compounds that makes them really interesting is that there is phytouptake, which means the plant brings the pollutant into its root system and up through the plant, becomes part of the plant and part of whatever crop or grain is being produced there. That is unique. A lot of the pollutants that we've been concerned about for decades don't do that. The older organochlorine pollutants, for example, things like PCBs, and our active ingredient pesticide formulations that do routinely get applied to farmland, they don't get uptaken by the plant, but PFAS does readily. And so we're seeing that the contaminated soils can produce contaminated crops. And that's true for both crops and livestock. And we heard mention of the stories coming out of places like Maine. Maybe you've heard some of these where farms were rendered inoperable due to the presence of PFAS in water and soil on the farm. If we put biosolids down that are high PFAS, eventually it's going to work through the soil zone and contaminate the groundwater. And now the farm is dealing with it on both fronts. So those scenarios have played out in places like Maine. So anyway, we're trying to understand how this is working on the farm. Here's another diagram that helps us understand how we go from industrial uses to wastewater and leachate that comes from landfills. So when we landfill high PFAS containing materials, often the leachates from those landfills go to our wastewater plants for treatment. The plants are not able to completely deal with those, and we have effluent that's coming out with PFAS. And from all of that, we have biosolids coming to the farm and uptake into the food system that eventually leads to risk to humans through consuming contaminated food and drinking water. So this is the way that things are appearing to be working now. And since I only have another minute or so, I'm going to move over to some of what's happening at EPA. So we have a strategic roadmap that's been in place for a couple of years. There's a progress update that is just about to be released. If you have any interest, of course, here is the URL to read it. And I don't think there is a program. We refer to them as AA ships in EPA. We have water, and we have pesticides and pollution prevention. In all of those major divisions of EPA, there are multiple things happening with PFAS. It's absolutely an amazing thing that we're observing where EPA is reacting to this and moving out as fast as we can. Couple of things here. We have proposed drinking water limits for PFOA and PFAS. The proposed values are 4 parts per trillion. It's 4 parts per trillion because that's the lowest that we can detect routinely. That's where the technology is right now for detecting it. If we could see lower, we would have proposed lower. The toxicity tells us that we should have none of this in our water, but we have to set our limits at a place where we can detect so that we can regulate, and that's 4 parts per trillion for these two. Comments are being reviewed right now. We should have final drinking water limits there soon, and drinking water systems will have 3 to 5 years to come into compliance. There is a risk assessment underway for PFOA and PFOS in biosolids. And that's due to be completed in 2024, and it will be the basis for additional consideration of other regulatory actions to try to ensure that we have the right quality of biosolids being applied in places like our farms. And the two that are getting most of the attention, PFOA and PFOS, will likely be designated as hazardous substances. That allows our RCRA, which is our waste program, and CERCLA, which is Superfund, the emergency cleanup of our worst contaminated sites. They will then be able to leverage that designation within their programs. And finally, we're waiting for aquatic life and human health criteria. And that's going to really help EPA and our partners in the Chesapeake Bay watershed, the states in particular, and DC, do a better job of evaluating what we're seeing in our surface waters and in our fish, and do a better job of understanding what risk that presents when we have these final criteria. So that's just a small sample of what's happening at EPA right now, and if you visit this website, you can learn a lot more. I think the risk assessment in biosolids is one that will be particularly of interest to this community. In 2024, we will have the final risk assessment, and we'll see where that leads with regard to enhanced regulation of biosolids. So I think that's about the time that I had, and we'll take questions later. Okay, thank you.
Hi, I'm the lawyer. I'm going to talk to you about the legal exposure of farmers. Do you have some colorful slides to make it turn your mic on? Sorry. Oh, I got it. That shows turned on. Hello? It lights up. Hey? Okay, I'll do this one. I was saying I'm the lawyer on this panel, so I'll talk to you guys all about the legal exposure of farmers and other food manufacturers to PFAS. I do have some colorful slides to make you think that what we're talking about is not quite as depressing. They're not up yet, so you'll see cheerful pictures in a little bit. But what I did want to reiterate, I was going to explain to you as well, how is it that these compounds that were first 60, 70 years ago invented for heavy industrial use, how do they affect farmers? How do they come into the food supply? I think Greg covered a lot of that. The only thing I wanted to sort of encourage you to think about, it could be really overwhelming when you first hear all of the science. It's a lot of chemistry. That was not my strong suit in college. It's seemingly everywhere there you go. Don't you feel happier now? Okay. When I walk into my own house, I feel like I see PFAS labels popping up everywhere, even though I'm a very, conscious consumer. But in terms of farming, in terms of food production, I would encourage you to think of it in like 2 buckets. There is historical contamination that like the farmer can do nothing about, whether there was a manufacturing plant, whether there was leakage in the soil, whether there was, previous biosolids application that they don't know about. That's just kind of there. And until those smart folks at the various universities come up with ways for us to clean up our soil and clean up our environment, there's not really too much to be done. But there's also, nope, not clicking. Can someone fix this? But there's also current contamination and future contamination that is dependent on what farmers use in their farming practices. And so things like compost, for example, which tends to bring really high on PFAS because it relies on paper products that are saturated through and through with the various PFAS compounds. compost, both normal traditional farming compost and also organic compost, has been shown to contain high levels of PFAS. Pesticides, as Greg mentioned, just 3 days ago, the European Union conducted a study that said that 12% of so that 12% of all pesticides, but in all pesticides, 12% of the composition is basically straight up PFAS. So that's really staggering, scary numbers. The same goes for sludge, fertilizers, biosolids, and then animal feed grown on contaminated soil can then cause a lot of trouble down the line for farmers who are using it, because then it shows up in the milk and in the meat. In addition to the actual farming techniques, there is also another route of contamination, which is through food packaging. So a lot of the paper products that we use in restaurants, a lot of the packaging, both plastic and paper packaging, can leach PFAS into the food that it comes in contact with. Greg mentioned the HDP containers that house pesticides, but they also house your yogurt and your orange juice and all things like that. Processing equipment on farms, milking equipment tends to be lined with PFAS, so as the milk comes in, that picks up PFAS on the way. Now, not at the risk of being alarmist, right? So I do need to point out that all of that has been established. PFAS is in all of those places. What we are lacking currently is sufficient number of studies that tell us how much of that transfers onto food. And depending on what testing methods are used, what medium are used, and who you ask, you kind of get a little bit of a different answer to that. But those are just things to keep in mind. And so as a result of that, the very, very scary picture, as much as it's going to look cheery on the screen, is that PFAS have now been found, despite very scarce testing, they have been found in plants, in produce. So things like kale this summer showed up with really high levels of PFAS, including organic kale. They have been found in dairy, they've been found in meat, they've been found in eggs, again, including organic eggs. That was the big scandal back in February. They've been found in all manner of fish, shellfish, and then even in packaged products like pasta, tomato pasta sauce has been found to have a lot of PFAS, and we don't really know, did that come from the tomato that was grown on a farm that was contaminated? Did it happen in the processing plant? Did it happen because of the packaging, or all three? So that's really, really bad news for consumers. You guys can keep clicking through them, but there's more. So there is really bad news for consumers. In terms of legal liability, Megan said what is finally happening with PFAS, because PFAS has been something on the back of everyone's mind for a few years as the studies are coming through, but not too much has been happening in previous years. This year has seen quite a bit of legal development and regulatory development from EPA in particular, in drinking water, and in now, as of 3 weeks ago, there has been a new, very widespread requirement for reporting the intentional addition of PFAS in all manner of products. As far as farmers are concerned, the good news for farmers and the bad news for consumers is that there's currently no legal exposure for farmers because of the presence of PFAS on farmland. All of the regulations that have come through either don't at all implicate farming and food supply. They're not. FDA and USDA have done basically nothing as far as regulatory outreach for these things, or some of the rules like the Toxic Substances Control Act rule that just came out a few weeks ago, they specifically exempt farming, they specifically exempt biosolids, they specifically exempt food production. And so the legal liability for farmers currently is basically non-existent. There's no federal or state requirement in Maryland to test for soil or for contamination in groundwater. There is no requirement, if you happen to test, to actually divulge those testing results. That's not the case in all states. Maine, for example, is actually having a systematic effort to test farmland. And the reason why you're hearing a lot of horror stories coming out of Maine is not because they have an unusually high level of contamination. They probably have less than the rest of us. They're just testing more, so we're hearing more about it. But there's no such things happening in Maryland. In terms of future liability, this issue is not going away. Forever chemicals are here to stay, unfortunately, and so is the issue of PFAS liability. And so going on in the future, there might be additional things that are happening. The USDA is starting to maybe slightly randomly test farmland, and so that could keep ramping up. But I didn't feel comfortable speculating past 2024. So in 2024, potential future liability could arise from CERCLA. As Greg mentioned, they're considering adding at least PFAS and FOA to the Superfund liability. And so that means that the EPA might start testing more land, especially land that's adjacent to military bases, airports, and other high contamination areas. And they might be engaging in cleanup efforts, but again, that's not very likely to cause any direct liability to farmers unless farmers were intentionally and knowingly pouring gallons of PFAS onto their farmland, which I don't think anybody is doing on purpose. Same with RCRA. The most relevant thing to farmers in the state of Maryland is a likely rule that could come out in 2024 prohibiting pesticides containing PFAS. Currently it's stuck in committee, so it's anybody's guess what's going to happen with it. But the state of Maryland engaged in a study about the presence of PFAS and pesticides, and so it started to take action about that. But again, that is not likely to actually create liability for farmers. It's likely to help farmers, because if that rule goes into effect, then the products that are going to be legally on the market in the state of Maryland are going to be PFAS free, or as close to that as we can hope. And so that provides more alternative for farmers to not continue the cycle of vicious contamination that we've been dealing with for years past. That said, the lack of legal liability is not the end of the story. As we are seeing from examples in Michigan and Maine and Texas, the economic realities are that if PFAS is found on a farm, the consequences can be devastating. The financial burden of cleaning up, to the extent cleanup is even possible, are tremendous. Most of the time, farmers have had to euthanize their cattle. They've had to basically shut down operations, and there's very little they can do to move on from there, because no one wants to buy contaminated land. There is not anything that they can do with the land in the agricultural space to help their operations continue, maybe like rebrand or something like that. The depreciation of their brand is significant. And so even though PFAS legal liability is not an issue for farmers, it is still a really important topic to be aware of, and to try to move away from practices that continue and perpetuate PFAS contamination on farms, because the reality is that if farmers are producing produce or milk or meat that is contaminated with PFAS, eventually the consequences will catch up, and they're not pretty. And I did want to end with some good news on the next slide, if you could call them that. I wanted to talk about potential avenues, legal avenues for relief if farmers are actually facing issues with contamination, whether from their own testing or private testing or government testing at random that may have happened. So one avenue for relief is the USDA Dairy Indemnity Payment Program. The USDA has this program specifically for dairy farms that have shown contamination with PFAS. As you could probably imagine, it's fairly underfunded. And so even though only a few farmers, writ large, only a handful of farmers have had to deal with this, even still, the funds are already depleted. It remains to be seen what the new farm bill, whenever it is that we get it, does with funding these programs. We're probably going to have to wait close to a year to see what happens there. But as you could imagine, the financial pie that they're trying to apportion between the different programs is finite. And so it's not very likely that this would be funded beyond the current level where it's at, but it is something to keep in mind to the extent that that happens to individual farmers in the state of Maryland. There's currently no such provisions for Maryland farmers from the state of Maryland. There is currently an act called the Relief for Farmers Hit with PFAS Act that is pending in committee. It's been read twice in the House, and that's where it's at right now. There's current advocacy to include that act as part of the big farm bill, but nobody has seen a draft of the big farm bill, and so we don't really know if they're going to include it or not. If that act were to pass, that will actually provide significant relief for farmers hit with PFAS, because it provides for testing, it provides for research, for opportunities to, maybe there are crop resistant, PFAS resistant crops that we don't know yet, and maybe those crops can be used in rotation for a farm while the farmers are dealing with decontamination. There's also indemnity payments, not just for dairy farms, but for all manner of farmers, and additional support that is provided for in this act. But right now, it's just a nice idea, and we don't really know if it's going to come to fruition. I should mention that there are ongoing private, like class action litigation against the manufacturers of these compounds, as well as state-led litigation. A number of states, including Maryland, have joined litigation against 3M and DuPont and Chemours, the companies that created those PFAS substances back 67 years ago, and evidence now is coming to light that they knew all the entire time as they were marketing it to consumers what these things do, both to the environment and to humans. And so one potential avenue for relief for anybody impacted by those is to either join a class action, private class action against those companies, or to talk to their state AG and see what the state of those class actions or litigation is. Some of them have been successful in settling. The settlement amounts are in the billions, which sounds exciting until you start thinking about how many people are actually affected by that. And so again, it's a limited pie that then has to get split up by many claimants. But a lot of that money has gone for medical monitoring of people who are exposed to heavy PFAS doses, or for income replacement and other damages that may have been caused by PFAS contamination. And finally, and again, that's not in Maryland, but Maryland has actually been one of the states that have been on the forefront of moving through PFAS issues. And so it's something to potentially look forward to down the line. Maine, as I said, is the leader in this space, and what they have done is they stopped waiting for the federal government to figure out how to support farmers better. And so in addition to protecting consumers by actually more systematically testing farms and removing product from the market that has been contaminated with PFAS, they have also worked not to leave their farmers hanging. And so they created a $60 billion program that is funding farmers and helping them recover or figure out what else to do with their contaminated farms. They're also funding significant amount of research efforts, both for how to decontaminate soil, which, as Greg mentioned, is currently not something that we know how to do, and also the potential uptake in plants. We're not really sure if there are plants that are more susceptible to PFAS and plants that are less susceptible or maybe even resistant to PFAS. We're not really sure if PFAS stays more in the root or the stem or the leaves. And so all of that kind of knowledge can help us move through this crisis in a more systematic way and in a less devastating for farmers way. And so again, even though that's not in Maryland, just the sheer fact that those efforts are happening somewhere is a little glimmer of hope. But also it's a wonderful blueprint for states that are interested in moving that way. And Maryland is one of those states that has been more progressive on this issue. So that is something to potentially look forward to in the future. That's my attempt to make a cheery ending to what is otherwise, as I said, a depressing topic, but I'm excited to answer any questions that may come up.
Amazing. Thank you so much. That was heavy topic. I'm going to hold on to that glimmer of hope really hard. Does anybody have any questions about PFAS and agriculture, remediation, or class actions? Oh, and if you're online, if you're on Zoom, please put your questions in the chat box if you have any. Oh, Elizabeth.
Okay, I have an online one.
Oh, yeah, Elizabeth.
From online, can you talk more about the symptoms of harm in humans or animals related to PFAS, and how are they treated?
The range of health impacts from these pollutants is incredibly wide. I have seen lists for human health impacts that are at least 15 different health outcomes: obesity and cancer, lower effectiveness of vaccines, higher cholesterol. It's quite a long list of potential impact. That's the human health side. I don't know that we really understand much about ecological receptors, things like fish and other wildlife that are part of the system that is now also cycling PFAS through it. I don't think we know as much on the ecological side, but for human toxicity and human impacts, the list is very long. And our toxicity studies are suggesting that this can happen at very low concentrations. That's the toxicity side of persistent, bioaccumulative, and toxic. So it's a wide range of impact to humans from these.
Yeah, and just adding a little bit on the toxicity side, so the PFAS can roughly be divided into two groups. There's the long chain PFAS that were historically used, and then there's the newer generation of shorter chain PFAS, and they have different affinity to different tissues in the body. They have different half-life. Some of the longer chain, older PFAS were staying in the body for like 30 years. They had a tremendously long life in the human tissue. And some of the newer ones can move through your body in as fast as 24 hours. So what the industry spin on that has been, see, those are not nearly as bad. But what we're learning from medical science is that they act differently. The longer chain ones were attracted to fatty tissue, and so they'd go there and they'd stay there and slowly sort of degrade your health. The newer ones attack kidneys and other protein-heavy tissues, and so even though they go through in 24 hours to a few weeks, they can cause equal amount of damage in different ways. They're also more likely to go through the placental barrier, so they end up affecting the development of a fetus all the way through and affect children really heavily. On the legal side, as you could imagine, because all of the diseases that Greg listed are common in our society and have multiple different contributing factors, the biggest challenge on getting relief through the court system for diseases that could have, may have, likely were caused by exposure to PFAS is establishing that causality. One thing that anybody who believes that they live in a heavily affected PFAS area should do is go to their doctor and try to test their blood level. For certain of the PFAS compounds like PFOS and FOA that have been around for a really long time, CDC reports that 98% of Americans have those in their blood. But sort of getting a baseline of your exposure level is one way to document that. And then the court system has recently entertained claims that are called medical monitoring claims. So while it is hard to prove 20 years later that that precise exposure is what caused any sort of conditions, if you can prove that you live in a place that is contaminated, heavily contaminated with PFAS, you can sue the companies that created it or the contributors to the pollution and say that you owe me medical monitoring for the future, and I get my costs covered to make sure that every year I have those tests for the diseases that are linked to such heavy exposure, so that it's not 20 years later, a little too late, and you're wondering what's going on, but you can keep a more active eye on things. But yeah, the health consequences can be absolutely devastating.
Great. So for everyone who filled out the pre-conference survey, you had the opportunity to ask questions. So we have one from there. What laws have been passed in Maryland addressing this issue? You already kind of touched on that, but are there any state committees or commissions exploring the problem further? And have you seen any pre-filed bills for the 2024 season on PFAS in Maryland?
Yeah, I don't know if I specifically addressed that because it doesn't affect farmers, but SB 273, I believe, was the law that went into effect this past year. So again, Maryland is one of the states that's actually taking more proactive measures to banning PFAS. So as citizens, that affects you in the sense that as of this year, a whole host of products have to be PFAS free. So anything from carpets and upholstery to food contact materials, that has been the only thing that's affecting food. So if you go to your McDonald's restaurant and you get a takeout, that should be PFAS free as of this year in Maryland, and that's not the case everywhere else. And so it remains to be seen how that's enforced, because that has been one of the challenges that states that have done this in prior years have seen, right? The law is on the books. We're saying that those things need to be PFAS free, but both the availability of PFAS-free alternatives is fairly limited, and also for businesses that operate across state lines, it's harder for them to do that, and so it's harder for the state to enforce it. But yes, there is a law in the books in Maryland as of this year that's prohibiting the use of intentional addition of PFAS in a whole host of materials. And there is the law that I mentioned about pesticides that is currently being reviewed and is worked up, so that's scheduled to be looked at in 2024, and I believe there is a commission on the evaluation of PFAS in biosolids and sludge fertilizers, but I don't think that's made it all the way to a draft bill yet. I don't know if you know of anything else.
Excellent. Well, we have 2 minutes left. So does anybody have a quick question on this incredibly complicated issue? No? All right, I think we'll go ahead and
I have a quick
yeah, go for it.
agriculture joke.
Let's hear it.
Yeah.
Please, yes.
That was pretty heavy. So what vegetable is not allowed on cruise ships? She leaks. Very well done.
Yes. Thank you so much, Katya and Greg. That was an excellent panel. All right, we've got about 15 minutes for coffee and networking, and then we'll come back and start the next panel.